Okay, so in this video, we're going to continue talking about completing the square. I call this document completing the square day 2. With this lesson, we're going to do a little bit more challenging of problems with completing the square. What we did on our last homework were problems like this. X squared plus 6x plus 3 equals 0. If I said to solve by completing the square, we would do the following. Notice this expression is not factorable. There are no factors of 3 that add up to be 6. Like I mentioned in the last video, when your expression isn't factorable, your next step could be to try to complete the square. There are a few things I want you to notice, though, first, that I didn't really mention on the last video because you didn't really need to know it at that point. Every problem that I gave you, A was 1, and B was an even number. Okay, so basically what I'm saying is I gave you pretty easy problems, and the reason for that was I wanted you to get the basics down. I wanted you to get just a general idea of what completing the square is. Well, today we're going to take it one step further. A will not be 1 for these problems that we're going to do today, and B will not always be an even number. And you'll see how that causes us some issues. Okay. So just to refresh our memory, let's solve this one real quick. Move the 3 to the other side. Draw your boxes. And notice it's negative 3 on the right side because I technically subtract 3 from both sides. Okay. Notice that it's plus the red box on the left side and plus the red box on the right side because I have to keep the equation balanced. You're going to see later on today that matters. Okay. We discussed that our general formula is b over 2 all squared. In this case, b is 6. 6 over 2 is 3. 3 squared is 9. And I'm going quickly here because we have lots of examples to cover. Okay, that's where that 9 came from. When we factor, we're going to get x plus 3 all squared equals negative 3 plus 9 is 6. We square root both sides. We get just x plus 3 to the first equals plus or minus root 6. I try to simplify root 6, and it can't be simplified any further, so I'm going to leave it the way it is. That's an irrational number. And then subtract 3 from both sides to get x alone, and we get x equals negative 3 plus or minus root 6, and that is our answer. Okay, so those were basic problems we did last time on completing the square. Today we're going to take it one step further. Okay, our first example, 2x squared plus 2x minus 9. If you would, get out some paper if you don't already and follow along. Okay, and if you need to come back to this video and look at certain parts of it, you're free to do that. Okay, so this one, like I said, is different because there is a number in front of the x squared that is not 1. In this case, a is positive 2. Your general rule for completing the square is that before you complete the square, I'm going to type this here. Oh, that's a line. One second. Before you can complete the square, a must be 1. Okay, that is a rule. I didn't mention it last time because I gave you all problems where a was 1. All right, so think about how we can make a be 1 when right now it's 2. The way we do that is we're going to divide by 2 on both sides. All right, so divide by 2 on both sides. That's a perfectly acceptable algebraic move. And I'm going to write the result down here. All right, and we get just x squared plus x minus 9 over 2 equals 0 over 2, which is 0. All right, and that 2 that we divided by, it can go away. All right, because when we're solving an equation, when I do that operation to both sides, that means it can be removed. And when we factor, and we'll do that in the next video, that 2 that's in purple would have to stay on the outside. Okay, but that's for another day. All right, so this is our new equation. We haven't changed anything. We just changed the way it looks. Now we're doing the same problems we have been doing, but I'm sure you're cringing at this fraction. You can convert that to a decimal. Doesn't matter, but I'm going to keep it as a fraction for now. Just like before, step 1 is move that negative 9 halves to the other side. We'll do that by adding 9 halves to both sides. I'm going to do this, and then I'm also going to draw my boxes. All right. So what I'm going to get is I'm going to have x squared plus x plus the box equals, whoops, change color, equals positive 9 halves plus the red box. Okay. And then we complete the square. We have to have our general formula b over 2 all squared. In this case, b is 1. Like I said on the last video, we had all even numbers for b. Now we're going to have some odd numbers. So I'm going to have 1 over 2 all squared. All right, and 1 over 2 all squared. Do not grab your calculator for this. Just square the numerator and the denominator separately. 1 squared is 1. 2 squared is positive 4. All right, so that's the number that I'm going to put in my red boxes. Mr. Hulse, how in the heck am I going to factor this? Because that is our next step. How do I factor a trinomial where the constant term is a fraction? Okay, I agree this is a little bit trickier, but this is where you're going to have to rely on the videos and some key trends. All right, so if you remember what I underlined in blue, that is a perfect square trinomial. And when we have perfect square trinomials, what we're allowed to do basically is, if I will, and we're not literally square rooting these pieces because we're not allowed to square root 2 pieces of an equation and not that middle piece. But the ends are square rootable. And if we discussed perfect square trinomials right before spring break, the square root of x squared is x. The square root of 1/4 is 1/2. How did you know the square root of 1/4 is 1/2? Well, I look right here. I squared 1/2 to get 1/4. If I go backwards and I square root 1/4, notice the square root and the squared right here cancel out, and I just get 1/2, which is what I have down below. The second sign here has to be a plus. It is. If that's the case, this first sign comes down. I hope this is ringing the bell. If not, just let me know after you watch this. And it is all squared. Okay, so that's the left side. The right side is going to be, oh, almost forgot. Another way we have to check to make sure we did this right is to be able to take these pieces. So the x, multiply it by a half, so multiply these two together basically, and then multiply by 2, and if I did this right, then that value has to equal this here, and the 2 and the 1/2 cancel out, and I just get x. So we did do it correctly. All right. But once you do a bunch of these, you'll be really confident in your factoring. All right. The right side is going to be 9/2 plus 1/4. We can't add those fractions right now because they don't have common denominators. We're going to have to make them have common denominators. I'm going to make this 2 become a 4 by multiplying by 2. If I multiply the bottom by 2, I have to multiply the top by 2. And so if I do that, this piece becomes 18 over 4. Okay, 9 times 2 is 18, 2 times 2 is 4, and 18/4 plus this 1/4 is 19/4. That's another reason why these problems are a little bit more challenging, is because sometimes you'll get fractions like that. Okay? But in the end, don't forget, we are completing the square like always. We're just having to go, it's just a little bit tougher because of the numbers. All right, once I'm here, once I have that squared term that we wanted, I'm going to square root both sides. And I'm going to get just x plus 1/2 equals, do not forget your plus or minus, the square root of 19 over 4. Now, just like when you square a fraction, so remember up here, when I squared 1/2, I squared the top and the bottom separately. The same thing happens even if we're square rooting. I square root the top and the bottom separately if that's an option. It is an option because when I square root 4, I get 2. When I square root 19, I just get square root of 19. That's going to give me an ugly decimal, all right? And so this is an equivalent way to write it. If you want to just leave it as square root of 19 over 4, that's fine. But when I do it this way, and I subtract 1/2 from both sides, I'm going to have those common denominators, these two here. And I'll get x equals negative 1/2 plus or minus root 19/2, or square root of 19 over 2. Okay. If you want to rewrite this one step further, I'm sure you notice that we have common denominators. Final answer can be written as negative 1 plus or minus root 19, all divided by 2, and that will work. Okay, so that is example 1. Example 2. (4x squared). And these are not in your, I forgot to mention this, these are not in your workbooks, so you don't need those today. Just boring problems. And your homework assignment for this will be a worksheet. Okay, so if you're feeling confident with that process, I would definitely understand if you weren't after one example, but if you are, you can go ahead and pause the video and you can try to work this. Okay, so like I said, step 1 on completing the square is making sure that a is 1. Right now, a is 4, so I'm going to fix that by dividing all pieces by 4 and both sides by 4. And so if I do that, I'll get x squared plus, now 10 over 4, you don't have to do this, but I would reduce that fraction, and that can be reduced to 5 over 2. Notice I just divided 10 by 2 and got 5, and divided 4 by 2 and got 2. And then minus 3/4, so let's just leave that alone. And 0 over 4 is 0. Okay. So that is my new equation. I just divided both sides by 4. Now I'm going to move this constant to the other side, and then draw my boxes. Okay. B is 5 over 2, and this is another instance where I have a new challenging issue, and it's that B is a fraction. We've never had B be a fraction. So when I do this work, I have B over 2 squared, that's our general formula that we have to have memorized, and B is 5 over 2. And it's all being squared. That just looks confusing. But if you will use your parentheses appropriately, this is not too bad. You're dividing 5 over 2 by 2. Okay, so those parentheses I just put in red, if you'll put those there, that makes this a little bit better. When I divide a fraction by a whole number, I multiply those two bottom numbers together. And so what I have is 5 over 4, because 2 times 2 is 4, and that is still all being squared. And if I square that, I get 25 over 16. Okay. Like I said, you need to try to reduce fractions when you can, but this one cannot be reduced. 25 and 16 do not have any common factors. So I'm going to go ahead and put 25 over 16 in both boxes. All right. For space, I'm going to erase this work here, but like I've mentioned, if you need it, you just write it down and go back to that part of the video when you need to. Okay. Now I'm supposed to factor the square root of x squared is x. Well, this will always be a plus. I hope you've noticed that as we go. This sign isn't always a plus, but in this case it is. That's the sign that comes down. Oops, I'm gonna write that in black. The square root of 25/16 is 5/4. So just so you see it, square rooting the ends. This is all being squared. Now my job is to add these two fractions together. And like last time, we need common denominators. To make a 4 become a 16, I'm going to multiply by 4, but I have to multiply both top and bottom of that fraction by 4. That's going to give me 12/16 plus 25/16, which is 37/16, and that is what will go on our next line. Again, an ugly decimal that cannot be reduced, but that's okay. That's what we get on some of these problems. Okay, now we square root both sides. Oh, I apologize. I meant to change color. There we go. Okay. I'm going to get, after I square root, x plus 5/4 equals plus or minus. We're going to square root both top and bottom separately. So square root of 37 is just square root of 37. The square root of 16 is 4. Subtract 5/4 from both sides. And I get x equals, remember, what the negative 5/4 in green, whatever I move to the right side of the equation, that goes before the plus or minus. That plus or minus is always in front of that 37, or sorry, root 37. Okay, and then if you will actually add and subtract those fractions, we get negative 5 plus or minus root 37 all over 4. Right. And you're starting to see, I hope, that some of our answers to these quadratic equations are not pretty. Okay. Last time we were getting nice whole numbers like x equals 3 and x equals 7. We're getting into this territory with these more complex problems where our answers are ugly. Okay. Really quickly, I feel like you're ready to try one. And for the sake of time, because I'm already at almost 22 minutes, go ahead and pause the video and try to work this one. And then I'm just going to write the answer at the very end. And then if you have questions on how I got it, just email me personally and we can discuss that. Okay, hopefully you pause the video and work this, but the answer to number 3 is x equals 1 plus or minus square root of 5. Okay, like I said, if you need help with that, you don't know where you messed up or even how to do it, just email me. We can do Zoom. We can email about it either way. Okay, last example I want to show you. 3x squared equals negative 3x plus 2. Okay, notice in this one that the square term is by itself and that the linear term and the constant term are on the right side. So it's just rearranged a little bit different. My suggestion is I would just go ahead and start so you don't forget by dividing both sides by 3. Okay. And the way I wrote this, I technically should write it like this. Okay. If I do that, I'm going to get x squared equals negative x plus 2/3. All right. I need this negative x on the other side. So I'm going to add x to both sides. 2/3 is where it needs to be. So I'm going to do this, what I did in green, and then I'm going to draw my boxes. So I have x squared plus x plus the box equals 2/3 plus the box. Okay. B over 2 squared. In this case, b is 1. So I'm going to have 1 over 2 all squared, and that is equal to 1/4. That is the number that goes inside the red boxes. I'm going to erase this real quick. Okay, then we factor. I get x plus 1/2 squared. And again, when I got the 1/2 from square rooting 1, square root of 1 is 1, square root of 4 is 2. And then one last time, that sign came down. To add these two, I need common denominators. So here I'm going to multiply both fractions by something. The least common multiple of 3 and 4 is 12. So I'm going to multiply this one by 4 over 4. And this one by 3 over 3. Notice on both fractions I want a denominator of 4. That's going to give me 8 twelfths plus 3 twelfths, which equals 11 twelfths. So that's the number that goes here. Once I have that square term, whoops, I'm good to square root both sides. That gives me x plus 1/2 equals plus or minus root 11 over 12. Now on this one, root 11 is just root 11. Root 12 is 2 root 3, but I don't need to see that with this one. I'm good with you just leaving it like this. That is fine. Subtract 1/2 from both sides. And I get x equals negative 1/2 plus or minus root 11 over 12. Okay, now, if you wanted to be fancy and go ahead and simplify this, I'll go ahead and show how that would work. But I don't have to see it on this one. I told you that root 12 is 2 root 3. So look at the denominators of those fractions. They're pretty close to being the same. We have a 2 here and a 2 there, but this square root of 3 is the thing that's different. I'm going to give this fraction root 3 over root 3. I'm just getting the denominators the same. Okay? And if I wanted to simplify that, I would get negative 1 times root 3 is negative root 3 plus or minus root 11 all over that common denominator 2 root 3. Okay? But we don't like to have roots in our denominator. So we don't like to do that. So we like to rationalize the denominator, but I'm not going to get into that today. But that is completing the square day 2, basically where we have a not being 1. And your homework will be posted soon.